so we're back and we're looking at solving by factoring. So again, biggest things we want to make sure is we want to make sure the equation is set equal to 0. We want to factor completely, and then we want to set each factor equal to 0 and solve. And of course, we want to check all of our answers. All right, so let's come up with our very first problem, right? So example number 1 on factoring. So find all exact solutions, and this time we'll find it over 0 degrees to 360. Again, notice that 0 has a bracket around it because we want to include 0, but 360 has a parentheses around it because we don't want to include it, right? So when we start at 0 degrees, we want to go all the way up and get super close to 360, but actually not include it. All right, so here's our first problem. So we're going to say the cosecant of x plus 2 and the cosecant of x, oops, spelled cosecant wrong. The cosecant of x minus root 2 is equal to 0. Well, the great news about the first problem, right? Usually first problem is the easiest. It's already factored for you, right? So it's already set equal to 0. There's no need to multiply those binomials together. Don't do that. So I'm going to go ahead and I'm going to jump to the second part where, since it's factored already, I'm going to set each factor equal to 0. So here are my two factors equal to 0. The first one is -2. Now, I don't know about you, but I don't have cosecant memorized. But what I do know is that the cosecant is the reciprocal with sine, so this means that this is really the sine of x is equal to -1/2. So all I did is I flipped my fraction. Over here, this will be the cosecant is equal to a positive radical 2, so that means that the sine will be 1 over root 2, which is the same thing as root 2 over 2. So we have our two answers, right? Or two answers to our equation, but we haven't actually solved for x yet. So where sine is negative will be quadrant 3 and 4. So when we look at our unit circle, our two answers are going to be 210 degrees and then 330. For when your x is positive, when sine of x is equal to a positive number, we're looking at quadrant number 1 and 2. So that means that these x's are going to be your 45 and 135. So when we write our answers, usually you write it from smallest number to largest number. So 45 degrees, 135, 210, 330. And we have our answer. We do a quick little check. So let's check. So the cosecant of, let's say, 45 degrees plus 2, and then this would be the cosecant of 45 degrees minus root 2 is equal to 0. So 45 degrees, we have to remember that if the sine of 45 degrees was root 2 over 2, which is what we had over here, that means the cosecant of 45 degrees would be root 2. So this will be root 2 plus 2. Doesn't really help us, but it does help us over here because root 2 minus root 2 gives me 0. So 0, which does in fact give me 0. So we could do the same thing by plugging in 135, plugging in 210, and plugging in 330. So I'll let you guys try checking those on your own. Okay. All right, let's try another one. So what happens? So let's call this number 2. So find all exact solutions over 0 and 2 pi. Again, 2 pi instead of 360. So here it is. So 2 cosine squared x minus cosine x is equal to 1. So for this one, it's not equal to 0 yet. It's not factored. So let's make it equal to 0. So I'm going to go ahead. I'm going to move that 1 over to the other side. And again, you can kind of treat, if you want to, you can make a little let statement. So y is equal to the cosine of x. So this would be 2y squared minus y minus 1. if you wanted to do it this way. Again, we're just focusing on 2 and -1. Are there two numbers that will multiply to -2 and add to -1? There are. It's -2 and +1. So if I set this up, right? So again, I can either call it 2y squared or I can call it 2 cosine of x, either one. I'm going to do the cosine. This will be a -2 cosine of x and then just a cosine of x. So what do I know? 2 goes into both of those, so this should probably be 2 cosine of x, and then this will just be cosine of x. This has to be +1 because 1 times cosine of x gives you cosine of x. 1 times -1 gives me -1, and -1 times 2 cosine x gives me -2 cosine of x. So here are my two factors, 2 cosine of x plus 1 and cosine of x minus 1 equal to 0. Again, you don't fail the trig, you fail the algebra behind it. Now it's set equal to 0. I'm going to go ahead and set both of these factors equal to 0. So the first one will give me a -1/2, and the second one will give me a +1. Again, subtract 1, divide by 2. All right, where is cosine negative? I know I'm looking at quadrant 2 and quadrant 3. Again, I'm doing radians on this one. So my radians should be 2 pi over 3 and 4 pi over 3. For cosine x is equal to 1, there's only one answer. It's not in a quadrant. It's just 0. So here are all of my solutions. So 0, 2 pi over 3, and 4 pi over 3. Again, we can do a quick little check. So if I say 2 cosine squared of 0 minus cosine of 0 is equal to 1. So cosine of 0 is just 1. 2 times 1 is 2. So 2 minus 1 does in fact give me 1. And then I can test out the other ones. Okay. Let's go ahead and try another one. So let's do the same thing. Let's say find all exact solutions over 0 and 2 pi. So this will be number 3. Sine squared of x, cosine of x is equal to cosine of x. Now, when you're looking at this problem, one of the first things you might think is, oh, there's a cosine of x on both sides. Can't I just divide out the cosine of x? Could I just be like, oh, cosine of x, then everything goes away? No, don't do this. We are not going to divide it out. We're going to lose an answer if we divide it out. So make a hint, make a note right here. Don't divide by cosine of x because we might lose a solution. It doesn't always happen, but because it doesn't always happen and sometimes it happens, we don't want to do it. All right, so what do I want to do? I still see squared here, so I'm still going to try to factor. So I'm going to set it equal to 0 and then see what happens. So I'm going to subtract it to one side, and now I have cosine of x. I'm going to factor out that cosine of x. So I get sine squared of x minus 1 is equal to 0. It's still factorable. So then I'm going to set cosine of x equal to 0, and I'll set sine squared of x minus 1 equal to 0. Okay, again, I put it into radians. So my two answers for this guy would be pi over 2 and 3 pi over 2. For this, it needs a little bit of work. So sine squared of x is equal to 1. I'm going to take the square root. I am going to get plus or minus 1. So this will be pi over 2 and 3 pi over 2. All right, so notice that your answers do repeat, which is awesome. And so we're just going to have to write them once. So pi over 2 and 3 pi over 2. Again, we want to check our answers, so let's quickly check. So let's say sine squared of pi over 2 times cosine of pi over 2 is equal to cosine of pi over 2. So pi over 2 is 1, 1 squared is just 1, 1 times 0 is 0, cosine is equal to 0. So that does work out. And 3 pi over 2 cosine 3 pi over 2 cosine 3 pi over 2. So again, this will give me -1, but -1 squared is still 1. 1 times 0 does in fact give me 0. So again, it doesn't always work where sometimes like I'll divide things out and I won't lose an answer. But sometimes I will. All right. So our third method is going to be kind of similar to factoring, but what happens if we can't factor? So solve by quadratic methods. Okay, and again, we definitely want to check all of our solutions. So sometimes we do our square roots property. Right? So I mean that what this basically says is if we have x squared equal to k, where k is a number that's greater than 0, aka it's not going to be imaginary, then we can say x is equal to plus or minus the radical of k. No solution if k is less than 0, and then one solution if k is equal to 0. Important. Okay, and then what we can actually use is our quadratic formula, right? So if you have it in this form, it's not factorable. Well, then we get to use x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. But if we use the quadratic formula, use a calculator, right? So we still have to do a little bit of work with this. So on our next part 3, we'll come back and we'll start with these two quadratic methods.